Okay, picking up with the last domain problem here, I got cut off on the last video. We want to say that the value under the radical has to be positive, or could also equal 0. So x plus 2 is greater than or equal to 0, therefore x has to be greater than or equal to negative 2. In interval notation, that would simply look like bracket negative 2 to infinity. So with the domain problems, we'll continue with domain throughout this chapter. It's easier to consider where x values are undefined for some of these problems, especially when you have the rational and the radical expressions. Okay? All right. Just a few more examples here. I want to talk about piecewise functions. We're not going to graph them today. We'll do that later on this week. But piecewise functions are functions that, if you can see that, you have a couple different formulas. And what you do, we want to set up something like f of x. You know, we might have something like f of x equals 3x if x is negative. It could equal x plus 1 if x is between, you know, something like 0 and 2. And then we can even have something else for when x is positive or above greater than 2. Okay? So today I just want to make sure you can evaluate a piecewise function. So if I ask you to find, say, f of 1, you just look up, check the domain first. Again, that domain column are your x values. So x is 1, therefore x is between 0 and 2. Therefore, we're going to plug it into the function that corresponds to that, which is x plus 1. So f of 1 is going to equal 1 plus 1, or 2. Okay? How about f of 6? You know, f of 6 is greater than 2, so we're going to substitute that into the bottom equation. So 6 minus 2 squared, or 4 squared, or 16. Okay? And then finally, if we had something like f of negative 3, that's obviously less than 0. We plug it in for 3 times x, so 3 times negative 3, negative 9. Okay? If we had f of 0, what would that be? That does not fall under the first equation. It falls under the second one. So we plug it in again for this one right here, and we would get 1. Now, a good example, a prime example of, you know, when you would possibly set up a piece function would be a cell phone plan. So let's check this one out. We have a plan that's $39 a month. It includes 400 free minutes. This was before texting. I got this example. Charges 20 cents for each additional minute. And then the monthly charges are a function of the number of minutes used. So let's try and write that. The cost that you're going to pay for your phone is a function of the minutes. So I'm going to write C of M to represent that. Okay? Now we have 2 scenarios for the cost. We have a scenario when, I'm going to set the domain first, if our x value, or our minutes rather I should say, are between 0 and, what was it, 400. So if we have 400 or less minutes, then you're only being charged $39. So that would go there. Okay? But what happens if your minutes go above 400? So let's think about this. Okay? We're still being charged the $39. But now we're going to be charged 20 cents for each additional minute. So am I going to write 20 cents times M? No, because that would give me, I would be being charged 20 cents times, you know, the 400 minutes on top of the extra minutes above 400. So what we need to do here is rewrite this as my minutes minus 400. Let me erase that. I'm squeezing this in here. Okay? And that's what we're going to do if my minutes are above 400. So think about that. If we have the cost of, let's say you'd spend 100 minutes on the phone 1 month. Obviously, you're just being charged $39. Okay? But what if you're spending 500 minutes on the phone in 1 month? Okay? You're going to be charged $39 plus 20 cents times that extra 100 minutes. Okay? When we substitute in the 500, we're going to have 20 cents times that, and that adds up to $59. Okay? All right, so that's a good example of a piece function. Again, we'll do more with those later on the calculator. Okay, last example, we're going to use the calculator. So grab your calculator if you don't have it out right now. This example came right from the book. I just want to make sure you can manipulate some things on your calculator. Put parentheses in there like that. Okay, let me grab this up here for you. All right, so we have a function here that represents the weight of an astronaut when the astronaut is h miles above the Earth, so W of h. And the function is given as you see it there. And we are asking to make a table of values that give the weight at heights from 0 to 500, but in increments of 100. So let me show you how that works on the calculator, what we can do here. Okay, let's first of all plug in the function. So go to y equals whatever. Okay, so we're plugging in the function here. Be careful how you enter it. It's 130 times, so left parenthesis, 3960 divided by, now we need to put that denominator in parentheses as well, plus x. Close the parenthesis for the denominator and the function that needs to be squared, and then we'll square it. Okay? So now what we want to do is look in our table. I'm not sure how I have my table set up. Okay, so here we go. At 0 height, okay, when she's on Earth, she weighs 130 pounds. So if we want to put it in increments of 100, because we're doing 100 miles away, 500 miles away, go to table set, change your delta table to 100. I'm going to put this back on 0. I'm going to start it at 0. And then we've got a nice table here where we can look at and see what is happening as the astronaut gets further and further away. Okay? So once she is about 300 miles away, her weight is about 112. Okay? So we can manipulate our calculator and use our table that way pretty nicely, and then just answer questions from that. All right, so a little intro into functions, and tomorrow make sure you're prepared to work on the problems from 2.1, and then the second half of class we're going to look at the graphs of a lot of these functions. So make sure you have a calculator as well. All right, guys, see you tomorrow.